Well, I was asked to provide a little bit of background over here. First, I'd like to say all the data seems to be within the margins that we designed for. Even the surprises are within the margins that we designed for, which is very nice. This is the first time we've seen the whole system work together, and we were all waiting to see this data, all the entry, descent, and landing engineers. And it's really pleasant to finally understand how it really worked compared to all the different ways we thought it was going to work. The development process sort of looked easy during 4th of July, but the development process wasn't easy. I think we spent most of '94 trying to figure out what to do. And the conclusions that we came up with were the following. First, we couldn't test the whole system on Earth. The Earth environment just did not allow it. We couldn't have an end-to-end system test. So we had to break it up into bits and pieces, put them in as close an environment as we could get it into, and test it. Now the problem was, okay, you're testing components. We're not even sure what to test them to, what parameters to test them to, but are they going to hang together when they're on Mars? So what we ended up doing was an end-to-end computer simulation. We would input, our first cut at it was we would start with the trajectory requirements. We would input our desired performances of hardware that was already being designed and built, and then run the simulations and see what environments we wanted these hardware to be tested at. Next, we'd go test the environment, test the hardware in the environment we selected, post-process the test data, correlate it to a test computer simulation model, then take whatever we learned and project that into the end-to-end simulation model. Afterwards, we do another set of hardware tests. We'll change the hardware test parameters and do the simulation again. And this was an iterative process. We converged on results within 3 iterations. I'd say we had 3 end-to-end simulations, after which we were all comfortable that we understood how the system is going to behave. There were within our margins or within our expectations. To give you a little bit of idea of how this was done or what it took, besides the 3 of us over here, I'd say there were about 100 lead engineers working this all across the United States. Besides JPL, there were 3 other NASA centers, 4 major contractors, 2 major subcontractors, many other subcontractors, the China Lake Naval Air Weapons Center, Sandia National Lab, and a lot of different organizations and consultants that were involved here. Now, what we did, the hardware required, and a lot of hardware required for this, for entry, descent, and landing. Besides the 37 pyro events that was supposed to make it work, we needed the aeroshell, we needed a motor-deployed parachute, we needed bridle, we needed airbags, rockets. I think the only thing we didn't fly was the kitchen sink on this thing. We did everything on this mission. And we did almost 90% of verification over 1 year. We did in '95. During that year, we had 50 parachute drops. Many of them were full system drops. We had 2 rocket drops. Later on, we followed with 2 tethered rocket tests. We had maybe about 17 total development rocket firings. We had 17 airbag drops, full system airbag drops. We had 2 full system airbag deployments, and we had at least 8 gas generator firings. We had, I think we lost count at what point, more than 150 airbag retraction and petal deployment tests. And to give you a sense, all of them were occurring in parallel. They're all occurring with the hardware being built. They're also, everything is occurring with the end-to-end simulations being performed. So we were sort of on a roller coaster, running with it. And one thing I can say is that the roller coaster had a lot of painful downs and joyful ups. And it wasn't easy to get here. And I personally am very grateful to all the people that were committed to make this system work. Thank you. I'm done.
Yes. Tony, you're up.